Hello, everyone. Welcome to another recorded episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have a mix of topics, including attacking AWS Cognito, a fun path traversal in Node.js, and the rapid reset DOS in HTTP2. So I guess we'll lead off with that. So AWS, Cloudflare, and Google put out advisories about their recent dealings with an ODay, in quotations, that was being abused for denial of service attacks, dubbed rapid reset. And what it comes down to is HTTP2 and how it works with regards to streams. I don't think we've talked about HTTP2 too much on the podcast. We've seen some DEF CON talks in our coverage streams that talked about it. We may have covered a Portswigger post or two about it, but it's not super common in the posts that we cover.
Yeah, it's come up in some of the request smuggling content. Because I think we had the H2C attack that
Right.
was using the clear text that was the clear text one, and that was kind of HTTP. We've seen like some downgrade stuff, but nothing that was like really deep and technical into how HTTP2 worked.
Yeah. So I want to go into it a little bit of the background that's relevant. So in HTTP2, instead of the text-based header body format that most people are accustomed to in HTTP1 that we've seen on the podcast plenty of times, in HTTP2 you have binary streams where you can send frames back and forth, whether those be data frames or flow control frames. And you can keep sending traffic back and forth without opening new connections, and you can have multiple streams on a connection. The server can limit that. I believe the Google post said somewhere that it typically, like, you'll see like a limit of 100 or so. But the whole thing there is you can have multiple streams going at once of requests and responses, whereas on HTTP1 you'd have to send a request and receive a response one at a time. It's more serialized, and that opens the gateway to more resource utilization being possible by a single computer or a single client. One of the types of frames you can send is the RST stream frame or reset stream frame, and that can be used to cancel a stream, and it tells the server like cancel processing of requests from that stream. The problem is an attacker can just continuously bombard the server with these reset stream frames on a bunch of parallel streams, and the client will cancel out immediately, whereas the server is waiting to process those reset requests. So you can just kind of abuse that, send a ton of reset requests on tons of connections, and just bog down the CPU and bring down the server's ability to respond to further requests. So typically we don't cover denial of service too often on the podcast unless it's something sort of interesting in how it works. And I think this does fall into that category. It's taking advantage of a supported feature and leveraging that for the DOS. And it made some headlines, so figured we'd cover it here, but it really is just that simple. There's nothing super crazy going on. It's not like they're crashing the server or something. They're just hogging the CPU resources.
Yeah, like it
Um,
is a resource-based denial of service. Although
yeah,
one of the things is with that limited number of concurrent streams, so I pulled up the Nginx post on this, and they mentioned they have a default of 128 concurrent streams. And with that, like with this attack, because you're opening the request and then closing or because you're opening the stream and then closing the stream so rapidly, basically it's never actually counting up on the number of concurrent streams. So you're able to get quite a few more kind of smuggled through here just because of the rapid pace at which this is happening. And like Spectre said, it has that imbalance between how many resources the attacker needs to use in order to pull this off, in terms of they're just sending the reset stream versus the server is actually doing more work in tearing down that stream and all of that. So that's where you get the imbalance that creates a null service. Yeah, I mean, the noteworthy thing for me was that what did Google get here? Like 398 million requests per second. It was just used in pretty massive denial of service. And obviously Amazon and Cloudflare were also fairly massive, but Google was kind of the big number there.
yeah, for sure. So we won't spend too much longer on that, but I'm sure some of you that were listening had heard of what was going on there, and we don't get to talk about HTTP2 too often on the podcast, so we thought that'd be a good opportunity to do so. So up next at a HackerOne, we have a path traversal issue reported in Node.js, and this is a little bit more interesting. So Z, I'll let you get into it.
Yeah, it's a little bit more interesting, but it is also ultimately fairly straightforward. This is a part of Node.js. They're introducing this permissions module. And the idea there is kind of like a soft sandbox. it'll limit the things that Node can actually do. So when you use Node, you make the call to like open up something on the file system. You could actually specify through the JSON files, give it a policy of like this module is allowed to access these files or can do this or can access files in general. Has this whole configurable thing where you could set up the sandbox saying it's allowed to do whatever, but not these other things and limit what anything can do. And that's self-enforced inside of Node itself. And so the core bug here actually has been reported, or similar bugs have been reported a couple of times, because first they only did the path traversal, or only prevented path traversal attacks basically on strings. And then somebody's like, well, you can also send buffers through here. So if you send a buffer object, then it doesn't get checked for the path traversal. And then today's CVE is when you pass in a uint8 array, which is similar to the buffer objects. Buffer objects are backed by a uint8 array, but distinct enough that it would slip through the checks. And I actually pulled up the code for this, but I've also got the patch for anybody that's interested. Patch isn't anything too interesting, although they do one thing that I like here, which is on the original code, what they ended up doing, or so the original code's like if type of path equals string, resolve the path and return on that. This is a little bit more internal from where the check's actually happening, or a little bit deeper, trying to resolve it and then get checked. But what would end up happening is if you had, say, you have the permissions enabled, but you come through there with the uint8 array, it goes, well, is it a string? Nope, so it doesn't need to do anything more. Is it a buffer? At least with the first patch, is it that? Nope, and doesn't need to do anything more. And then just returns the normal path because it falls out of this permission check. The way they end up fixing this is, of course, to check, is this a uint8 array? I do appreciate the fact they toss in an assert there, so it's not just following the same pattern of if string, if buffer. Instead, what they've gone with is that assertion. So if somebody does find yet another way, oh, there's also this other thing you could pass in there that would work, this would now fail it, because if it's not this, it needs to resolve into the uint8 array. So I appreciate that choice there, just block off any more bypass, because like I mentioned, this was done a few times. But yeah, ultimately it is a pretty simple issue. It is just the idea of passing in variable types that are unexpected, which is something you see a lot out of JavaScript, out of PHP, a little bit in Python, but all these dynamic languages, when they just support passing around whatever, you've got to make sure you've got the right types. And in this case, their security check just didn't do that.
It's the kind of issue you run into when you allow input in multiple forms like that.
Well, it's the
Not too surprising to
language,
see it.
because this
Yeah,
is the
the
language.
language allows you to do it.
Yeah, like fundamentally, this is a language feature. Like the file system stuff is implemented and provided by Node itself. It's like the language allows you to pass in all these different things and tries to figure out what you mean. And it's a hard problem, like to think of all the edge cases, because usually you're developing something, you're thinking about the common use case, like somebody passes in a string. Of course, that makes sense. You're opening the string. And you don't necessarily think about all these other things that could be opened. So usually in terms of looking at this from like what's a code smell or what could be a code smell, it is seeing this check falling into the check and then only having the one or two types, but if anything else, not having a default case. Couldn't really switch on this one. Can't really switch the types. You could do the type of, but I'm not sure. Since they use buffer as buffer, I assume there's some shenanigans with what type of is going to give you. So yeah, can't really switch it, or probably can't. I don't know enough internally here, but not noticing any sort of default case to handle those unexpected cases, even if it's just something like default's okay, like it should fall through or something. But showing an awareness of that when you don't see that is slightly a red flag to me.
Yeah, and these sorts of cases cause issues at both the high level, like in this case, and at the low level, like some of you who will tune into our binary episode will also get a bit of a taste of. Yeah, it's a fun report. It's perfectly highlighting the kinds of issues you can run into in languages like JavaScript. So up next, we have a post on attacking AWS Cognito out of Rhino Security Labs, rather attacking setups that are using Cognito due to some configuration type issues. So this is a two-part blog post. The first part is mainly what we're going to cover, I think, and it's an introduction to AWS Cognito. For those who aren't really aware what that is, AWS's front-end solution for user auth and authorization, typically used for like web and mobile apps. And yeah, so this first post talks a bit about how Cognito works, mainly the fact that it has this concept of pools, where you'll have the user pool, which is used for managing registration and login information. They say you can basically think of it as an OpenID Connect identity provider, as well as an identity pool, which will generate temporary AWS credentials for a user to allow them to access various things you have stored in AWS services. And when they dug into it and how it's used in various client setups, they noticed some potential problems, particularly due to insecure defaults. So, one thing they noticed that often the client and the user pool, as well as the identity pool ideas, would be IDs would be reflected in the HTTP responses. So if an attacker can retrieve those responses, they could potentially obtain like IAM credentials. Another common find is that due to Cognito user registration being left open by default, an attacker might be able to use those client and user pool IDs to register, even if the application doesn't export like any login portal or ability to register. They can just kind of bypass the application on that. There's a few other notable things here too, primarily when it comes to privilege escalation. So the main thing they point out there is that the custom attributes that are used for role-based access control can be configured by the user by default, and other attributes that can be controlled by the user are case sensitive, including things like the email. And as we've seen in past topics, where that's case sensitive, if the backend is case insensitive, it can potentially allow account takeover because you could abuse the desync between Cognito and the backend. So, with all that in mind, Rhino decided to create two modules for Cognito in their Pacu AWS exploitation framework, which I'm not too familiar with. I think this is the first time I've really looked at it. I looked at the module code a little bit, but the modules are named Cognito Enum and Cognito Attack, and that's where the second post comes in. They go through what those modules do and show some examples. Um, the enumerator module will basically try to figure out what exactly you have access to in the AWS account, and it'll try to enumerate over the client IDs, user pool IDs, things like that. And it'll go through all of the attributes and check things like the password policy and the multi-factor authentication config to alert if a weak password policy is in place or if MFA isn't required. And it'll also try to enumerate identity pool IDs and see if it can pull access keys and session tokens and such for credentials. And then the attack module will try to again pull those credentials and try their various potential attacks, like registering an account, trying an email with a different case, assuming roles to escalate privileges, pretty much everything they talked about in the first post. So it's something to keep in mind, especially if you're looking to do engagements and come across AWS Cognito. I think this is a good reference to have. And like these modules in general are probably worth checking out.
Yeah, I think
And it seems like
references.
some pretty bad default configs, though, which is a little bit surprising out of AWS.
It's not that surprising out of AWS. There have
Okay, fair
definitely
enough.
been a number of defaults. I mean,
We've covered
AWS
them
and
before, but they seem to be generally better than some of the other cloud options when it comes to configuration. So,
yeah, I don't know. I've never really done the side by side comparison. It's just one of those things where cloud is complicated. Sometimes it feels like it's overly complicated, but there's definitely an argument that it's a necessary complication. And so this is just like a side effect of that and of some of that complications. But yeah, as you're saying about this post, like I think reference is a key word here. Nothing in here is some sort of crazy novel attack that you probably never imagined happening, but it is a good overview of attacks. And bonus, they provide some of the tooling for you to actually use and not need to implement it all yourself.
and side note, the tooling is actually pretty well commented and written. Sometimes when I look through tooling code for topics that we've covered, they're like kind of a nightmare to read. But in this case, it was pretty easy to follow.
So I
Yeah.
didn't take a look at the code. Is it written in Rust?
No, it's Python, so that helped in terms of readability.
Yeah, I would.
All right. An advisory was posted by Rapid7 and an analysis of a vuln that was exploited in the wild against Confluence Server and Confluence Data Center out of Atlassian. And I'll let Z take this one away.
Yeah, and this one's kind of fun. It's one of those issues that I see again on Loft trying to be dynamic websites. Java isn't the most dynamic language, although if you go way back with like Jackson Databind and some of those sorts of attacks, like there is a sense of trying to be a bit more dynamic and, of course, the object oriented nature. So fundamentally, they go into a lot of details over actually doing the patch diffing to find this and diving into the code a lot more. Fundamentally, though, the vulnerability I can find, kind of, they have this example here with X work, or part of the, I'm using struts here, part of that has X work. Basically, what the library is providing is a sort of translation layer through your web parameter information to actual objects, of filling in the properties of an object or whatever automatically. So they give the simple example here, and there's just a safe parameter interceptor. If you actually go take a look at this code, it's not doing anything too unexpected. They have, or at least this is the diff that's up here, but it has like some patterns that's trying to match like block parameter names, things like that. Like nothing too crazy. It's going to try parsing all these web parameters into actual objects though. So they have the example here of the form data dot name equals Charles. And that would get translated into something like get form data as a method call on whatever action you're actually running, and then set name Charles, which you see the translation layer there. Adds the get in front of whatever object you're trying to set, and then set for whatever the actual property is. Fairly standard. I mean, Java, people write getters and setters all the time. Fairly standard naming convention. It's just kind of working with that to set them. The problem is that kind of gives you this arbitrary method call and, well, yeah, I guess somewhat arbitrary method call and argument for the first value. And that's a pretty powerful primitive that you probably don't actually want to give attackers, but it can be difficult to exploit, especially in the blind, when you don't have insight into the code. But with some that is open source, or where you can, in this case, decompile some of the source, it's not, or, well, it still has some difficulties to find a gadget to use it, but you basically have that arbitrary function. And this can be nested. You can do like form data dot something else and nest these things through using the returns of each of those methods to get something interesting, just as you do in Java. This kind of ends up being one of those, just those primitives that it's hard to exploit without internal knowledge, but if you have it, you could almost always find something. And indeed, they did find a way of using this. Specifically, they end up using the server info action, and all they do is they set this bootstrap provider. I just want to see if I can find the string. There we go. They set this bootstrap status provider dot application config dot setup complete equals false, which gets translated into the get bootstrap get application config set setup complete to false. And with that call, they found that call would change the property for is setup complete on your Confluence application. So if setup isn't complete, now they can access all those setup actions like creating a new admin user, the first admin user. By setting that to false, they basically get it back into that setup mode, can create new admin users. It's a fun little attack there. I think just on a whole, this primitive is something I've seen in PHP applications too quite a bit, when they're trying to resolve down to like a PHP class file that's going to implement whatever page and then doing similar calls. Haven't quite seen it as this exact thing, but I've seen that sort of setup in PHP because PHP makes it pretty easy to do. But yeah, it's a fun little issue to keep in mind when you're testing. You may also be able to just raise errors by using arbitrary like parameters. So that's another thing to keep in mind. Don't just mind parameters, but try some fake setups to see what might come up here. At least in dynamic testing, that's one way of detecting that this is going on. But yeah, it's ultimately fairly simple issue. Just gives you that nice little primitive. I won't go into how they actually found the case to, or like the setup complete thing, but ultimately you can kind of imagine when you say setup isn't complete, you get access to all the setup functionality again, giving a unauthenticated access to Confluence where you can add your own admin and do whatever you want from there.
I like the way they took advantage of this. We've covered some topics in the past where they use like an access control issue or some kind of routing issue to be able to access like setup pages to do these sorts of attacks, but not quite in this way where you flip the internal tracking of if the setup is complete or not. I think that's a quite a clever way of taking advantage of the the arbitrary method call. Like, it's a nice gadget.
Yeah, it can be hard to look for like that sort of specific gadget because it depends on the application actually having something that would, like you said, it to false in any case. In general, like it should be something that you only ever write true to, and once it's done, it's done. But having the primitive that actually lets you set to false and return it after you've done setup to return it back.
It's
I
a
guess
gift
if after a upgrade or something, it does feel like a bit of a unlikely primitive in a lot of cases, but ultimately what you're doing with these bugs is you're looking for anything that you might be able to use to or leverage for other things. If it wasn't this, I'm sure there are other things you maybe could have called and gotten access to. It is nice that in Java, the getters and setters do have that very consistent naming that this framework lets you use or force you to use. So that does actually limit the methods that you can call. So if an application were to be using something totally different, this may be a lot harder to pull off. But yeah, just re-enabling it is a fun way to get it back there. It's a nice little attack, but I think in a lot of applications that wouldn't quite be practical, but we have talked about other bugs where they did find their way back into the setup somehow.
for sure. All right, so our last topic of the episode is from Maxwell Dulin and is on an RCE and Cosmos SDK. Z, I know you like this one. I'll let you get into it.
Yeah, this was a fun one. Cosmos SDK is for, I'm just going to say blockchain stuff. As a bug, like this isn't really a blockchain bug. This is, personally, I'd relate it a lot to log injection attacks, but I'll get onto that a little bit later. But effectively, you can imagine you've got this application here, the Cosmos SDK, and they have a process manager called the Cosmo Visor, which is operating as a watchdog. It just watches the actual application run, monitoring the standard out for events. One of those events is a chain upgrade proposal, which is just where members on the chain are like, hey, we want to upgrade the binary or whatever. So I don't know enough to actually comment on exactly what all it's updating with X. There are other aspects to the update that could happen, but effectively users can suggest let's do the update, users vote, it gets enough votes, then the application will send out this little message just saying upgrade, like here's the regex for it. If you're just listening, it's basically just upgrade name of whatever update needed at in some specific location on the blockchain. And then this upgrade JSON, which looks a little bit more arbitrary, but it just sends out this formatted line into the log that Cosmovisor will read, take note of, then potentially go take the link from there and grab the binary from it. They include kind of the information of how this is supposed to be structured there, including like the HTTP link, including a SHA hash on it, and some protective mitigations. But ultimately, the core issue here is if an attacker could gain control of some of the logging or the output of the application in such a way that they could inject this line without it actually having been original, like source or written in the original way, written from somewhere else, so a log injection attack, they could cause the application to download and execute a binary that the attacker controls, which is a pretty nice primitive to see in an application. And so they spent a bunch of time looking into this, one, figuring out if this was even a viable attack surface. Talks a little bit about failing fast, which some good advice in terms of actually approaching the testing here. Like you have an idea, try and fail fast, just see if you could do this. They do so just basically by injecting a print to see if they can cause this bug to happen or their suspected bug to happen. And from injecting that, if the bug does happen, so then they have to go and find the actual sync to do it. Talk a bit about trying to find it. They talk a bit about the actual logging structure here. And the key problem is the logger that they use, generally, it just expects the description, then some key value sets after that description. And if you provide a quote inside of the key or value, it's going to escape it. And so that ruins the regex to try and match it. Like the regex won't match anymore. So basically any sync like that isn't going to work. And what they found was that somewhere in this param module calls a format sprintf to basically recreate the logging format but putting all the data just in the description in that first parameter rather than the key and value. So one, that's just a bad practice. It feels like that could have been like really old code before they set up the logger structure how they wanted it. Somebody wrote this sort of thing where it's just format sprintf, because I can't see a good reason why somebody would write code like that when the logger gives them basically this exact same format without needing to do this sprintf. Like, it's just a very weird thing unless it's an intentional bug, but I don't necessarily want to say that because I have no idea. But ultimately, yeah, found this format sprintf that basically puts the key and value, things that they can control or the attacker can control, inside of the description, which means it's going to get reflected into the output, which means they can go back and inject its upgrade line and pwn the box. So yeah, fun. And it's one of those bugs where you need a lot of conditions to come right. So trying to fuzz something like this is difficult because you need the fuzzer to get like all that right string, get that and find it in the right place. Like, there's a lot of things that are needed. But that when you're thinking about the application, how it works can be relatively obvious. Is like, well, how do they validate this? And it's also, like I mentioned, reminds me of the log injection attacks, which are often I think, rather underrated attack, in part because it's really hard to detect when log injections happen. Usually you don't have insight into the logs. Even if you do, just an injection isn't going to do something. It's usually meaning the critical version of is when that log's being used as some sort of second order attack, something from the log gets used elsewhere, like in this case. But I do like to see it because log injections, I think, are a very overlooked class of bug because there are a lot of cases where, frankly, they don't mean very much. But there are cases like this where they do. So yeah, I like this one. It doesn't really require much understanding of the blockchain aspect. The bug itself is just a bug you can expect to see in pretty much any sort of like desktop application that does any sort of logging. Of course, web apps too, but I don't know. Feels a little bit more desktop-ish to me, but yeah, could be web too. Totally fair on that. I did appreciate the insight into the process where he's talking about spending like a week on this or hitting their head against things. I like seeing that in the post. And I appreciate the talking about, as I mentioned, the fail fast concept. Just test your idea before you spend all the time trying to find this actual bug that they could then use to test it. Just make sure the bug actually exists. If it doesn't, you don't need to waste your time on the other part. And you can look for something more interesting.
Yeah, it's nice to occasionally get the blockchain issue that doesn't take like an hour and a half of reading through it to try to understand it. It's nice to get these more accessible ones.
Yeah, I
And
mean, I'm
yeah,
sure.
it's got some log4j type vibes to it.
Yeah, I'm sure a lot of those blockchain bugs that take a while to understand are also just needing to get all the background because I haven't done a lot of it.
Oh, for sure. But that's what I mean. Like this one, you don't need a ton of that background because it's more of a, I guess, higher level issue. So,
And while we're talking about though, I will mention that Maxwell Dillon here, he also has this resources page. Awesome page, summarizes vulnerabilities similar to what we do actually with our vulnerability page. Does a bunch of summaries. He does a lot more of the blockchain bugs end up on here. So if that does interest you, it would be a good resource just as something to skim for those blockchain bugs to get the summaries of them, similar to what we do, but a bit more of the blockchain focus. I don't know. I appreciate his write ups here, or like his summaries.
yeah, we shouted it out before. I think he was actually doing it before we were even doing that with like we were still covering topics on the podcast obviously, but I don't think we were doing the summaries on a public page
Yeah, I never
before he was doing them.
compared like how far back he went. He has 124 pages here, so probably
It's a lot.
covering them before. Yeah, looks like that would be older than even our podcast. So goes
Yeah.
back a good way on some of them. Point being, it's a pretty solid resource. I just wanted to shout it
Yeah.
out since we were talking about the crypto bugs. He definitely covers a lot more than we do.
All right. So that's all the topics that we have for today. So as always, thank you everyone who tuned in. Previous episodes can be found on YouTube, Spotify, Apple Podcasts, and more links on Anchor. Discord and Twitter links are down below in the description. And we'll be back tomorrow for the binary episode, and we'll see you then.